Yeah, hi everyone. Welcome to this session, almost the end of the day. Session is called For Desktop to Cloud. We're doing it with Aurora or AWS. We have some really cool use cases to show for using Houdini outside of its typical use cases. So I'm here presenting together with Tor.
Yeah, my name is Tor Holmem, and I'm from a company called Arkwiz. All right, so the question we started out with was, what if an end user could harness the power of Houdini without needing to learn it? So using all the cool tools that you have in Houdini at your disposal without even knowing that Houdini is even running. At the beginning, this was not really a straightforward question to answer, and this is where Project Aurora comes in.
All right, so that's why we're announcing Project Aurora today. Project Aurora is a collaboration by my company Bismuth, together with SideFX as well as AWS. And what we wanted to do is essentially provide a framework that we can give to the Houdini users and people that aren't using Houdini yet as a way to leverage the power of Houdini on the cloud. And so one of the use cases that you can do with this is, for example, what Tor from Arkwiz is doing, which we'll talk more about in a bit. So to start out with, let's talk a bit about what Project Aurora is. So the project itself is a ready-to-use AWS infrastructure as a code tool. It's an extensible functional sample for pipeline people or for people that would want to use Houdini on the cloud. And it primarily focuses on use cases beyond your farm submitting workflow that many people already have a solution for if you're in a studio environment. So really think about users beyond a game studio, film studio, TV, advertising, etc. This is, for example, for companies that currently might not even know what Houdini is yet. And so it's published as a repository on GitHub. It's live as of today. And you can download it and you can use it right away. It's also all free. It's open source, has an MIT license, so you can do with it whatever you want. But it's also important to know, what is it not? It's not a Houdini turnkey software as a service solution that you can just use for those kind of purposes. It's also not a farm replacement, as I mentioned before, and it's also not a new SideFX product or service that SideFX offers to its customers. So this is a sample for you to start with, to extend with, to do awesome things with. So that begs the question, why would you want to use Houdini on the cloud in those use cases? Well, it allows you to run Houdini from any client. So imagine that you, for example, are a company that is trading an app. Let's say you're a jewelry manufacturer and you want to sell jewelry to your customers and allow them to customize jewelry before they actually order it. And they want to use Houdini for that, let's say, right? You don't want to be teaching those customers Houdini, right? You probably also can't run Houdini on a mobile phone when they're customizing it, right? So you need a way to leverage the power of Houdini without running it on a machine. So that potentially abstracts Houdini away from non-Houdini users while still exposing them to it. You can also run it at any scale because if you only have one desktop, you can only run one instance of Houdini, and you can do more if you're smart. But volume and throughput no longer becomes a limiting factor for what you can actually do with Houdini. If you need one instance, that's great. If you need 5, if you need 10, if you need 100 instances running at the same time, that's no problem. You can run it at any scale you want. You can also run it on any hardware specification, right? So taking that tablet example or browser example doesn't have a lot of compute, right? But you don't really need that if you have Houdini running somewhere else. So that means that your specifications are no longer a limiting factor for what you can actually do with Houdini. Do you need 1 gigs of RAM? Do you need 100 gigs of RAM? Do you need 1,000 gigs of RAM? Bob's your uncle, you can use cloud for that. Another big benefit is that on cloud compute, you only pay for it as you go for what you actually use. So if you want to use Houdini, for example, in a studio or another environment, you typically need a quite beefy desktop, right? And those are pricey. And that means that you need a large investment right when you start using, Houdini in your environment. But if you use it on cloud, you essentially pay for that compute as you go for what you actually use. If you only use it for 1 minute, you pay for 1 minute of usage. And of course, you need a Houdini license. But cloud sounds awesome so far. Why isn't everyone doing it? Well, it's very confusing to a lot of people. You need to know what cloud is, what are the infrastructure you need to build, how do all these services work together, what services do I even need? I need to worry about security, I need to worry about all sorts of different things. So that's a big barrier of entry for a lot of people. And so that's why with Project Aurora, we're essentially doing that part for you. You don't need to worry about provisioning the cloud. You don't need to worry about the runtime aspect of the cloud. The only thing you need to worry about as a user of this project sample is essentially the Houdini aspect. You build an awesome Houdini graph for whatever purpose it is that you want to do, and you can execute it in a cloud environment. So let's look at a couple of scenarios. Let's say you are Moritz, and Moritz is a smart guy. He can create awesome things in Houdini. He builds his Houdini files. He gives Houdini instructions of what to do, for example, by sliding parameters or giving it inputs. It works. He gets an output, BGO, and he can use that. Now, Moritz is very proud of this, and he shares his setup with Mai. And Mai tries to run it on his computer, but it doesn't work. Mai doesn't have Houdini installed. Mai doesn't have the license server installed. Mai might not have certain plugins installed, might not have Python installed. So he needs to do all of those things before he can actually start using the file set Moritz shared with him. So it just doesn't work for him right away. So Moritz, being clever, what he does is he essentially takes his environment and he packages it up in a Docker image, essentially bundling all of the dependencies, everything that you need in order to run Houdini, Houdini itself, certain plugins, the license server, making sure that that works and is connected, Python, every other dependency that you need. And he puts that in, think of it as a box, right? Now, the only thing that Moritz needs to do when he wants to use Houdini is put the files that he wants to execute inside of the box, as well as the instructions of what to do with those files. And then as an output, he gets his files. He doesn't need to worry about what happens in the box. He just knows that that box will do whatever I need it to do. So he takes his box and he gives that box to Mai, and Mai doesn't necessarily need to know what is happening inside of this box. The only thing that Mai knows is if I put a Houdini file in there and some instructions, I suddenly get a BGO back. He doesn't need to worry about all the different complexities that may arise with using Houdini in that environment. So once you have that box, you can give it to John from AWS, and John will put that box right there where it needs to be in the cloud infrastructure. So essentially taking that box that you've created, putting it on AWS, then allows you to use a cloud infrastructure, right? You can take that box and spin up 10 instances of it, or 100 instances of it, and send them your files with instructions, and it will actually execute it and give you back your result. So I'm going to talk a bit about what we've built on top of this, starting with some intro stuff here. So we call GEOS, which is our product, a new standard for pre-visualization in the AEC sector, meaning the architectural, engineering, and construction sector. So in a nutshell, we take map data and we turn that into 3D environments that we render in Unreal. And this becomes then the GEOS application. And the whole reason for this is that we allow our users to put their planned projects into this context to get a better idea of how things will be in the future when those projects are realized. So very briefly about us, we're a very small startup based in Norway. We are partners with a larger company called Geodata, and they are building all their products and services on top of the Esri platform, which is important to us. So our customers are the larger companies that are building stuff, and the stuff they are building is often large. Whenever you're building something, it will have an impact on the location where it's being built, whether it's a large-scale housing project, wind turbines, infrastructure.
it's always important for these companies to inform both the public, governments, governmental bodies, and customers about how this is going to be in the end. Now, this is known as pre-visualization. It's not exactly a new thing. And the way it is usually executed is that they do still images or videos. And the problem with this kind of approach is that it's time-consuming, which means it's expensive. The perspective, both in terms of both in the video and in the still image, is locked. So you can't really turn the camera off to the fact. And the two images on the far right side here represent the type of, engineering data that is sometimes exposed to the public as being like, oh, this is what it's going to be like, which of course nobody understands. And this leads to a lot of ways to lose both money and time. So our purpose is sort of, what if you could get any location at the press of a button, rendered in Unreal, delivered in the browser, and is still directly connected to the source data? And that's what we did. So on a high level, the user will enter their ArcGIS workspace, represented on the far left here, and they will select an area of interest, and they will just simply click Go. And everything that Paul is talking about, or at least parts of it, is represented by the box in the middle here. And the end result is a pixel stream, meaning that the application is also running on the cloud and is brought back to the user. So as a more practical example, this is what it looks like. On the left-hand side, we have the RTIS operating system or program. And on the right-hand side, we have our interpretation of the same scene, which then has been calculated in Houdini, brought into Unreal, outputted, brought into the application, and streamed back. So these are actually two programs that seem to be running at the same time, but they don't really know about each other. And this is actually kind of a project that we made as a demo. There's a bit of hands-on in this one, but it is a very good example of what we're building towards. And we have been doing several of these projects in the past to get to know our customers better. And it turns out this kind of, on-demand digital twin is useful in many scenarios. So here, for example, we have some flood visualizations, again with the wind turbines, and of course, what we started out with, which is architectural visualization.
So the pieces of the puzzle, I keep talking about this box and it just runs on AWS miraculously. I also wanted to give a bit of context on what is actually happening in order to get this to work. Like, what is Project Aurora actually at its core and at its foundation? Like, what is it you get from this code? So as I mentioned before, it's just code that exists on GitHub that you can clone, and it has a lot of scripts that you can actually run, right? Everything that will run locally as well as on the cloud is defined as scripts, is defined as files that exist in this repository. With it comes a Conda environment that you can just simply install. All of this is described in the README, which allows you to have a local dev environment containing all of the Python dependencies that you would need to install, because we want to make it as easy as possible for you to just only press run and it will just do its thing and not deal with, hey, why doesn't it work on my version of Python and so forth. It just installs a nice environment for you with everything in it. It also comes with a Docker file for Houdini. So everything that you need in order to run Houdini inside of Docker is described in this file, installing Houdini itself, the license server, any other dependencies that it may have. Again, it's all text, right? If you have specific requirements that you would also need Houdini to have access to, you can extend this, you can remove things, whatever it is you want to do. Once again, it's open source. And then you can build it, which will build a Docker image that you can run both locally to try out things, as well as it being the image that is being executed on AWS. So it's easy for you to evaluate whether or not things work and to just develop very quickly. So how do you tell Houdini on the cloud what to actually do? And so what we've come up with is essentially what I like calling a work directive. And this work directive contains all of the settings, essentially, that you need Houdini to know. So to begin with, you of course specify what is the HIP file we want to execute, because what you're uploading to the cloud is a zip file that contains your Houdini file. It contains this work directive and any other things that you might need. So this means that you can upload multiple HIP files at once, and it will just execute all of them with the settings that you specify. So how does it know what to modify, right? Because you don't just want to run a HIP file and just use it as is. You can also specify all of the settings that you want it to use. So here, for example, very basic example to simplify things, you can specify what are the file inputs you want to set, what are the parameter values you want to set, including some metadata, such as what kind of type is this that you're setting? Is it just a literal value you're setting, or are you also feeding an input as a file into the scene, and it will tell you, hey, this file exists or doesn't exist for better debugging. The other thing that it, of course, does is it allows you to specify what it is you actually need to execute, right? Because it's not just setting parameters and that's it. It actually needs to also run something. So you can do things like specifying which buttons it needs to click, or which nodes it needs to cook, or which things it needs to export. The other thing that you, of course, need is something called an AMI on AWS. And an AMI stands for Amazon Machine Image. Because you can imagine when you talk to this John person at AWS, they just give you the hardware, right? It's just a brand new computer, doesn't have anything installed on it, no drivers, nothing. It's just pure metal, essentially. And what this AMI describes is what do we need to install on this thing? And so essentially it's installing Ubuntu, it installs the NVIDIA drivers if you need a GPU, Python, Docker, and everything else that you would install locally on your computer if you wanted to use Houdini, essentially. So it's like a complete image of everything you need to run this thing. So now the computer knows what to put inside of that box, right? The other thing that we do, of course, is provisioning AWS. And what does provisioning mean? Provisioning means describing and creating all the individual services that run on the cloud infrastructure for them to work together and know what actually needs to happen. So it's basically orchestrating how everything works, when it should run, and so forth. Basically, it generates the architecture diagram that you see here in the cloud environment. So once you've run that script, with setting up Project Aurora on your machine, you essentially can log in onto your AWS console. You can go in there and you can look at all the individual services. You can see the cost that you've made and so forth. So for example, you don't need to care about all the networking settings and those kind of things, right? Like Project Aurora sets that up for you. And again, if you needed to customize it, that's totally doable because it's all open source code. No need to look around in the console on AWS. You just modify the scripts that are defined locally. So I mentioned before that you upload a zip file for the instances to execute. That's done through S3. So what you can do is you can create that zip file. For example, on that tablet, when you have your app where you're modifying things, you would at runtime just generate a simple zip file containing either a pre-made HIP file that you already have, think of it as an HDA, as well as that JSON that you can generate at runtime. For example, what are the settings that you want the HIP file to be executed with? Then what you would do is you would copy the URI of that file. And again, I'm showing it here in the interface in AWS, but all of this also runs in script if you want it to be completely headless. And then what you can do is you can just run a certain command. I've provided a sample script that allows you to kick off such a process on AWS with the zip file containing the work directive as well as the HIP files. And it will then let you know once it's done, right? And this can be seconds, can be minutes, can be hours, depending on what you're doing. And then if you look online on the console, you can actually also see all the instances that are running and see information about them, see logging, and so forth. Now, let's say you've done your processing and you like Project Aurora, but you're not going to use it anymore. It's often quite complicated to actually get rid of all the individual services that you've created. So we also added the utility that allows you to just nuke the entire environment and it's gone. So you no longer have any costs associated with what's running on the services anymore. So now what? What do you do with that and how can you extend it?
Yeah, so as I mentioned before, sort of the middle box we saw there is Project Aurora for us. It is actually the execution of especially Houdini on the cloud, but it's just a part of our service. So I'm going to talk a little bit about what happens after this has happened, because generating the environment is just a piece of it. We need to allow our users to put these projects I was talking about into that world. And for this, we are relying also on the S3 RTIS Maps SDK for Unreal. And what this is essentially allows us to take a URL of a data set that usually lives on ArcGIS and stream it directly into our app. So this is what I meant when I said that the data is live connected. This is the source data that the engineers and the architects are directly working with. They can be fairly complex, and we can also filter them based on attributes. And these kind of CAD data or BIM files is one type of the 3D we can bring in. We can also stream in entire 3D meshes. So in this case, a large scale drone scan of Oslo. And pointing out in the middle there is the building that we just had a look at. So you can sort of mix and match. We can have both the CAD file, the drone scan, our generated world, and we want to allow the user to sort of specify what is important to them. In some cases, our generated world would be enough. In other cases, you would want this kind of higher fidelity. And one thing that's kind of exciting that we have just started with is the ability to bring over points, lines, and polygons. And as I'm sure you guys can appreciate, there's a lot of magic that can come from just a humble polygon. And the important thing here is that the user are defining these in the map. So they can draw these points or lines and polygons and bring them over. So again, as a practical example of that, we built a demo here with for wind turbines, and they are usually represented as points. So if you pay attention to the turbine in the middle of the image here, I'm going to move it a little bit in the map and click update. This is a demo, so I have to refresh twice. But then this turbine will then move in the live application. It's becoming a bit more apparent when I'm changing the properties or attributes on these points, which then talks to the blueprint inside the Unreal Engine app, in this case, making it comically large. So these kind of live back and forth, building like a super simple data set like this is exciting to us because we can build all kinds of tools on top of this. So Houdini is an absolute powerhouse, and it is a perfect tool for the job that we are trying to do. It allows us to take, in this, there's a bunch of data sets, but here I just picked out the laser scanned terrain data that exists for all of Norway. And on the right-hand side are something called green structure maps, which define vegetation at a pretty narrow scale. Unfortunately, Houdini is sort of meant to be run on a desktop, and this doesn't help much. Our clients are supposed to be doing this themselves in the cloud. And that is basically what Project Aurora has allowed us to do. So I just wanted to point out that that is the beginning. You will customize it to whatever you need, and then you can further extend it. So we have our own API and backend. Of course, everything we build in Unreal is unique. The pixel streaming logic and also the live data systems that I mentioned, this is sort of on top of Project Aurora. But you can still abstract it into this. So I think of Project Aurora as sort of like a factory with Houdini in the middle, where we, in our case, input map data and turn that into stuff that can be used in Unreal. But it really could be any input and any output. And that's what's kind of exciting about this project. So at the very end, I just want to mention that GEOS will be released to pilot customers early 26. And if there are any Houdini or Unreal developers or artists who think this looks cool, don't hesitate to reach out. We are looking for more hands on deck in the near future. Yeah. Cool. We're not done. Seems like I was closing that. We're not done.
So some details, right? Because you may be wondering, oh, this looks awesome. What are some of the details and nuances here? One of them you're probably wondering about is, what does this cost? Cloud is probably very expensive, right? That's actually not the case if you know what you're doing, and that's what we're helping you with Project Aurora. So here are two examples. So disclaimer, I'm not saying that these are the actual prices for you, right? It's just an example that I took a couple days ago. So if, for example, you need an instance that only has a CPU and no GPU support, and you have 32 vCPUs, 128 gigs of RAM, 10 gigabit internet connection, lots of storage, you pay $1.60 per hour, right? So if you do 10 minutes of compute, it's a fraction of that, right? If you do 100 hours of compute, it's 100 times that price, right? For the AWS compute aspect of it. If you do need a GPU, for example, if you also need to run Unreal as part of that, like for example for Project GEOS, you take an instance with similar specifications for the CPU and the system memory, but you also have access to a GPU. The cost then is $2.30. And again, if you use 10 minutes of compute or 1 minute of compute, again, it's a fraction of that. In terms of Houdini itself, licensing, there's two methods. You can make use of annual rentals. You need a Houdini engine license. So if, for example, you have a floating license pool, you can make use of that on AWS. Alternatively, you can also make use of burst licensing. If you're interested in that, reach out to SideFX or AWS. Some debugging tips, because again, you're dealing with a computer essentially that's somewhere else, potentially on the other side of the world. How do you actually know what's happening if things go wrong, right? Because not everything always goes right. Things also fail. And so we need to be able to understand what is happening. So to do that, we also added CloudWatch support to this project, which allows you to log literally everything. So if you just run the sample as is and you send a Houdini file, everything that's happening, you can track and see what is happening. So how does it work and look like? If you log into the console and you open up the CloudWatch interface, you can see all the logs of all the runs that you've made before, right? And so in this case, I'm just going to click on one that I quickly ran. And what we can see is that everything that Houdini did in terms of logging into the license server, processing the Houdini file, any other print statements or whatever else, or logging or creation of files or whatever it is you would like to log and track is tracked in here. So essentially, if you were to work in your terminal or your computer, basically everything you would see there, you would also see here. So that's a really nice indicator that helps you with this. The other thing you can do is if you need more direct access, you can of course also SSH into a computer. And so what SSH essentially means is that you are controlling or have access to that computer through your terminal, right? And so in the instructions, we show you how to create an access key, which allows you to log in and connect with that computer, the one that you're using for processing. And then what you can do there is essentially run any command you really want, because you can see at the end, we are then controlling that instance through our terminal. Project Aurora, it's live on the content library right now. So if you're interested in trying this out and reading about it, you can go there, you can download it, try it out. You can use it right away. Again, open source, free, MIT license. So what's next for Project Aurora? That's kind of what we are currently defining. And so I think one of the interesting aspects that we may be looking at is how you can do that part after the Houdini section, right? How can you, for example, make use of Houdini as part of your web browser or on your phone or any other use cases that you may be interested in? So that's what we're currently looking at. With that, it's the end of the presentation. I have a couple of extra slides since we have some more time, so I'll probably just go to those really quickly. You may be wondering, why don't I just use a local farm? That's a legit, valid question. There are pros and cons to either, which you can see here. I won't go over all of them, but some of them stick out. So if you have constant, continuous loads, and you know what the size of that is going to be in terms of workload, and you have a local farm, it makes more sense to do that, right? So if you are a film studio and you submit jobs to a farm continuously, day and night, it makes more sense to just use your local farm. But if you don't know how much compute you need, at what volume, at what scale, on what kind of hardware, it makes more sense to offload that to the cloud, right? Because you can scale it as wide as you want, as large as you want, and essentially you're not investing, like I mentioned before, a lot into your local system. So at the bottom, best use cases. Are you dealing with day-to-day steady workloads? Local farm or server makes more sense. If you are doing a lot of burst or short-term scaling or super large scale, cloud makes more sense. And again, in terms of cost, local is of course a fixed cost. You can calculate everything in front, what it's going to cost. With AWS, again, it depends on your workload. So there's a bit more variation there. Some other useful tips. So like I showed in the work directive, I also save out a debug HIP file. And what that means is the file that you feed in, all the parameters that you're setting at runtime. We also save a cached version of that HIP file so that you can download it, open it up locally and see where did it go wrong. So that's also uploaded to S3. Now, a quick sneak peek of something that I've also been working on is this. And what you're seeing here is actually Python running in the background. It's doing all sorts of compute that I'm controlling through my web browser. So this means that I have my web browser and I'm actually streaming the viewport from Houdini in my browser, meaning that I have the interactivity of Houdini, while the cooking is completely separated in a different process running elsewhere. And this means that I can have my computer, in another room or on AWS, do all sorts of compute while viewing it and interacting with it locally. So imagine that you have an HDA that you just want to show to someone else. They don't have Houdini. This could be a potential use case of showing that, even potentially commercializing it. And again, this is also fully extensible, so you can customize, all of the browser aspects of it, as well as the compute backend side of it. And with that, I will go back to the end slide and ask if there's any questions. Thank you.
Hey, I was wondering, I don't really get the point of that directive file with specified parameters and stuff. Is that if you want to run the same file with different parameters, or is it because you rebuilding that entire file and setting those parameters?
No, it's not a recipe that would describe your network. Your network is already defined in your HIP file. The work directive allows you to run different variations of your HIP file. So for example, in that jewelry example, if you need, let's say 10,000 variations of some model being generated with your Houdini file, you essentially would have a lot of entries that would allow you to essentially create wedges using it. So it's just a way of describing wedges, if you want to call it like that.
Oh, okay, got you. That makes sense. Thank you. Nick has a question over there.
I'm not familiar with Python at all. I'm just wondering what the differences are between that and then TeamViewer, VNC from if I needed to look at something on my computer and I'm away. Just wondering what the differences are.
So in the TeamViewer example or VNC, you are actively using Houdini on a computer, right? The use cases for this is someone that just wants to run things in the background without even looking at Houdini or without even knowing what's happening, right? The only thing that they care about is creating variations, such as, for example, the GEOS use case, where the end user, who is an architect or just a potential user, on the street somewhere, they just want to generate an Unreal map with interactivity so that they can see what GEOS generates. They don't know that it's running on the cloud. I also don't want to give them, hey, here's a TeamViewer login, go log in on the machine and play around with Houdini and Unreal so that you can see what's happening. You only want to abstract all of the compute to the experience that you would like to offer to such an end user.
Okay, that makes sense. Thank you.
Hello, hi. I have a question about the pixel streaming. The reason that we are going the whole way of opening the file, changing the parameter, and then do the export, and then opening back into Unreal, instead of running the HDA directly into Unreal, a stream just Unreal out, is because you want to have that. Basically, in your presentation, you had a browser open on the side, and then you have Unreal on the other side. Is because the browser cannot handle the Houdini engine? That's why you're going step 1, step 2, or is another reason?
No, so the pixel streaming is actually streaming a game, right? So what's happening on the cloud is we get map data, like Tor explained. We put that in Houdini. Houdini generates, the terrain, the buildings, everything else. That gets exported to disk. Unreal will generate a level from it. It will then package that game, and that game will be, deployed and run as a pixel stream. So it's not an actual. Houdini is essentially out of the picture after the compute is done.
Okay. Slight variation. If I want to have just Unreal running in the cloud, but Houdini will run as Houdini engine because I don't care about the baking aspect of it. Will that speed up my visualization at that point? Basically just loading the HDA, then having Python basically running in the background.
Yeah, so you're essentially talking about user-generated content, right? Or level editor or some capabilities in your game. That's exactly the type of thing that you could do with this as well, right? Because you no longer have access to your editor, right? Unreal editor. Houdini Engine also isn't middleware in the sense that it ships and works at runtime. So with this, you can essentially have an environment like we just showed, do your compute, generate, for example, points where you'd like to instance things, and stream that back to your game, and then have that instance things at runtime.
Okay, thank you.
They go, Rick. That's okay. Yeah, I see nodding. Thank you. It's really cool. One question about the logging. You mentioned you can log anything you want, print statements, etc. Let's say I upload an HDA and I expect the user to use some kind of input, but they don't provide that input. They provide something else, and some node is erroring. Is there a way that that error is being propagated to the log for me to see what went on?
Yes, yeah, that's also already built in the sample that we give you. So it will try its best. The error catching in Houdini is a little bit convoluted sometimes, but it will try its best figuring out where things went wrong. And so, like I mentioned earlier, there are some safeguards already implemented where if you, for example, say, hey, I have a file that needs to be used as an input and that file is missing, it will just right away not even do any compute and say, hey, this file is missing. But if, let's say, due to something in your network it fails, it will try and do its best in grabbing the error that Houdini gave and just also put it in the log for you.
Amazing. Thank you. One question for that preview at the end with the viewport and where you were like tumbling in the browser. I saw like little gizmos. Those were added on the browser itself just for visualization, or are they actual handles that you can interact with and they feed back data into Houdini?
This one here, you're talking about the little gnomon that's in the middle. That's from the browser itself. But if you wanted to do handles, you would need to write some, GL on top of your browser here to do that, and then propagate those things to the browser. So you don't have actual access to, if you have the Houdini transform gizmo and just use it as is. I mean, you could technically, but this is not what this is right now.
Okay, and click.
Right, that's all the time we have. Questions? Thanks, guys.
Thank you.
I did.